let us verify the formula n of A union B equals to n of A plus n of B minus n of A intersection B with the help of a diagram.
From the diagram, A union B is equal to the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Therefore, the number of elements in the set A union B is 11. Now the set A equals to 1, 2, 3, 4, 10 and 11. Therefore, the number of elements in set A is 6. Similarly, the set B equals to 1, 2, 3, 5, 6, 7, 8 and 9. The number of elements in set B is 8. The set of elements in A intersection B is 1, 2 and 3. Therefore, the number of elements in A intersection B is 3. Now, substituting these values in the formula, the number of elements in A union B equals to number of elements in A plus number of elements in B minus number of elements in A intersection B equal to 11, which is equal to 6 plus 8 minus 3, which is equal to 11.
Now, we have to prove that the number of elements in A union B union C equals to the number of elements in A plus the number of elements in B plus the number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in C intersection A plus the number of elements in A intersection B intersection C.
Now the set A equals to 1, 2, 3, 4, 10 and 11. Therefore, the number of elements in set A is 6. The set B equals to 1, 2, 3, 5, 6, 7, 8 and 9. The number of elements in set B is 8. Similarly, the set C equals to 1, 2, 4, 5 and 6. The number of elements in set B is 5. Now the set A union B union C equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. The number of elements in set A union B union C equals to 11. Now set A intersection B equals to 1, 2 and 3. Therefore, number of elements in A intersection B is 3. Set B intersection C equals to 1, 2, 5 and 6. Therefore, number of elements in B intersection C is 4. Set C intersection A equals to 1, 2 and 4. Therefore, number of elements in C intersection A is 3. Now, set A intersection B intersection C equals to 1, 2. Therefore, number of elements in A intersection B intersection C is 2. Therefore, number of elements in A union B union C equals to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in C intersection A plus number of elements in A intersection B intersection C. This implies that 11 equals to 6 plus 8 plus 5 minus 3 minus 4 minus 3 plus 2 is equal to 11. A survey conducted on 60 families of a locality reveals that 40 families subscribe for the daily e-Nadu and 25 subscribe for Varta and 15 families neither. Using Venn diagrams, answer the following. How many families subscribe only for e-Nadu? How many families subscribe only for Varta? And how many families subscribe for only one of them? Let X be the number of families who subscribe for both e-Nadu and Varta. Now let us represent the given information in the Venn diagram. Draw two circles, one to represent the families who subscribe for e-Nadu and another one representing the families who subscribe for Varta. Since we assume that the number of families who subscribe for both as X, write it in the common area of the Venn diagram. Now the number of families subscribed only for Enadu equals to 40 minus x. The number of families subscribed only for Vartha equals to 25 minus x. That is, while writing the number of families who subscribed only for one paper, we have to remove the number of families who have subscribed for both the papers. The number of families subscribed neither of them and is given as 15. Now the total of number of families we subscribed for only Enadu, only Vartha, both Enadu and Vartha, and neither of the papers will give a total number of families in the locality, that is 60 families. Therefore, 40 minus x plus 25 minus x plus 15 equals to 60. Therefore, 80 minus x equals to 60. Therefore, x equals to 80 minus 60 equals to 20. Therefore, the number of people who subscribe for both the papers is 20. And therefore, the number of families who subscribe only for Enadu equals to 40 minus 20 equals to 20. The number of families that subscribe only for Vartha equals to 25 minus 20, which is 5. The number of families subscribing for only one of them equals to 20 plus 5, which is 25. Out of a group of 70 students, 25 play basketball, 30 play football, 24 play kabaddi, 10 play basketball and football, 9 play basketball and kabaddi, 12 play kabaddi and football, and 5 play all the 3 games. Using a Venn diagram, find the number of students who play none of these. Let us represent each of the information with the diagram. Represent the universal set, that is the total number of students, as a rectangle, which is equal to 70. Now draw a circle to represent the number of students who play basketball. Draw another circle to intersect the previous circle to represent the number of students who play football. Similarly, draw a third circle intersecting the earlier circles to represent the number of students who play kabaddi. Number of elements in set F equals to 30. Number of elements in set K equals to 24. Now, number of elements in B intersection F equals to 10. The number of elements in B intersection K equals to 9. The number of elements in K intersection F equals to 12. And the number of elements in B intersection F equals to 10 intersection K equals to 5. Let us fill the Venn diagram first. The students who play only basketball and football is 10 minus 5, which is 5. And those who play only basketball and kabaddi is 9 minus 5, which is 4. Finally, those who play only football and kabaddi is 12 minus 5, which is 7. Now, the number of students who play only basketball is got by subtracting all the values in the circle representing basketball, which is an orange circle, from 25. That is, the number of students who play only basketball is 11. The number of students who play only football is got by subtracting all the values in the circle representing football, which is a blue circle, from 30. That is, the number of students who play only football is 13. The number of students who play only kabaddi is got by subtracting all the values in the circle representing kabaddi from 24. That is, the number of students who play only kabaddi, and that number is 8. The number of students who play any of these 3 games is got by adding all the values in the circles, and that is 53. Who played none of this game is got by subtracting the number of students who played any of these games from the total number of students. Therefore, the number of students who played none of these games is 17. If mu is equal to the set of all triangles, A is equal to all isosceles triangles, B is equal to all equilateral triangles, and C is equal to all right angle triangles, D is equal to all acute angle triangles, then what is the nature of elements of the sets A intersection C, B intersection D, and C minus A. Solving for 1, A intersection C. All isosceles triangles intersect with all right angle triangles. We get right angle isosceles triangles. B intersection D. All equilateral triangles intersect for all acute angle triangles. Therefore, we get equilateral triangles. C minus A. All right angle triangles minus all isosceles triangles. We get non-isosceles right angle triangles. That is only C.
I hope this class gave you a very good insight on the concepts of the set theory. Continue practicing until we see each other the next time. Thank you. Bye-bye.